Hey everybody, and welcome to Chapter 4. Chapter 4 is going to link almost completely perfectly with Chapter 3. So Chapter 3, you may remember we talked a lot about how we are able to perceive very basic features such as lines and light. This chapter we're going to be taking it a step further, and we're going to be talking about how we take those lines and those pieces of light and how we combine them into fully fledged objects. All right, so what we're going to do this in, I think, 4 separate videos. The first video is going to cover this piece right here where we're going to be talking about visual search, so how we look for things in space. The second video is going to be about feature integration theory, which is how we are going to put together all of these features. This is something that we kind of talked a little bit about in Chapter 3. The third video I don't actually have on this outline is going to be about recognition by components. So we'll talk a little bit about something that we're going to call geons. And then we are going to finish up by talking about face perception in the fourth video. And face perception we'll be looking at in the ways in which perceiving a face is similar and how it is different than perceiving other objects, regular common objects. All right, let's get into it. All right, so I'm going to give you a very quick demo. I'm going to give you 3 of these different trials. I want you to look for the vertical line here, and I want you to tell me, or I guess you can't tell me, but I want you to reflect on how fast you're able to solve this particular task. So you're looking for the vertical line. Here we go. Okay, that one stuck out right at you, right? Popped out right at you. So that pop out is because it just seems to stand out, right? It's the only one that is vertical. Okay, let's try it again. I want you to find the green colored line. This one might be a little bit harder. Here we go. So think about how fast you can do it. Okay, again, this one kind of sticks out at you, right? It sticks out at you again for the same reason that essentially it is the only one that seems to have this property that we're looking for. All right, and now for this final one, I want you to look for the vertical red colored line. So you're looking for a red line that is standing up. Here we go. Think about how fast you can do it. Okay, so this one, probably you were fast, but not as fast as the others. You were a little bit slower here, right? And so the whole point of this, and this task is called the visual search task. It is one of the oldest cognitive psychological experiments that we have. It has been done since the beginning of cognitive psychology. People have been interested in these kinds of questions. What this research has found is essentially that it's not necessarily the properties of this stimulus, it's the combination of the properties of the stimulus. And then we've already evidenced this. We've already shown that because it took no time for you to find the vertical line, and it took no time for you to find the line that was a specific color. But it's whenever those things are combined that they get to be difficult. But more than that, it's whenever there are distractors that seem to be sharing some of those properties as well. So the big overall picture of all of this is that it's not just whether or not a target has multiple properties, is how many of those properties are shared by other things in the environment, things that could potentially be distracting, that could grab your attention. They're called distractors. Sometimes you'll hear them called foils. But basically, the more of those you have and the more they share with that specific object, that specific target, the harder it is for us to process it. And this may not be a revelation to some of you. Some of you already know this because you were like me and you played this game whenever you were growing up. What is this game called? This is Where's Waldo? And actually, I found out just a couple of days ago that it's called Where's Waldo in North America only. Everywhere else in the world it's called Where's Wally, which I feel like doesn't really flow off the tongue nearly as well. But if you're not familiar with Where's Waldo, basically this is a game that usually children in elementary school have in these books that you get at the Scholastic Book Fair. You're looking for this individual right here. You're looking for this bloke. So this guy, his name's Waldo. He always wears the exact same thing. He's got a little white and red snow cap and a white and red shirt and blue jeans. And he's got on glasses and he's got brown hair. So in every one of these pictures, you're supposed to be looking for this individual. So he kind of stands out, and I know depending on how big you have this video, it may be kind of hard to see him, but you can Google this and you can find lots of images on your own. But basically, he should stand out. If he were in our classroom, he would stand out, right? Because the shirt that he's wearing is very loud. That white and red stripes is a very vivid, noticeable shirt. So he should be easy to find in a crowd, right? But you'll quickly find that he's not so easy to find in this crowd. He's somewhere in this crowd, but where is he? The reason why it's difficult is because you'll notice that lots of things seem to share let me see if I can change the pen color. Let's see, maybe blue might be better. You'll see lots of things. No, that's worse. I'll just make do. You'll see lots of things that seem to share these different kinds of features that we're looking for. These white and red stripes. And we got white all over the place. We have lots of red all over the place. We got white and red combined into stripes all over the place. And so these things distract us. They grab our attention. And so it's really hard to find where's Waldo. If we were to take this whole thing and if we were to turn it black and white and just leave Waldo's shirt white and red, this would stick out to us no problem, right? Instead, we have to search for him, we have to look for him, and then eventually we'll find that he's right here. So if you can see that on your video, that's where Waldo's at. He's pretty much right there in the center of the visual field, but he's kind of hard to notice because of all the different distractors that we have. All right, how do we pick up on these features? How do we detect these features in the first place? The way that we do that, the way that we're going to talk about it, is more of a conceptual way that's called feature net detectors. And the way that this works, what this is essentially calling back to chapter 3. You may remember that we had these different neurons that were firing whenever we had specific light or specific light orientations, so different angles of light and things like that. So we have these different kinds of cells that are going to fire more frequently or less frequently whether they see certain kinds of lines. That is going to be our feature detector layer of the brain. And again, think of this more in conceptual terms. It's kind of an abstract, simplified way of thinking about it. So we got these feature detectors. And above that, further down the stream of our processing, we have specific layers of the brain that are going to be looking for letters. So they help us notice, recognize, and understand letters. So, for example, if we are given these neurons that are firing these three different kinds of signals, these different kinds of curves, then we have this part of our brain is going to recognize, oh yeah, that's a C. We've learned that is a C. That's what we're looking for. And we find two lines that intersect at a right angle. We're going to say, oh yeah, that looks like an L. And so on and so forth for the rest of these. And then further down the stream again, we're going to have another part of the brain that is going to be looking for words, the word detector. And so that is going to be looking for, well, what letters do we have? So you can think about it like this. When we are perceiving a word, and indeed really any object, it's just easy to think about them as words for this example. But if we're looking for a word, what we're looking for are specific letters. And so depending on those letters, that will tell us about the word, and we're looking for those specific features that will tell us what letters we are looking for. So that is kind of a very bottom-up way of thinking about it, that we have all of this activation that comes from these different kinds of features that we see. But as we talked about, things like language, things about like recognizing text, and indeed any other kind of visual perception, is a balancing act between bottom-up and top-down regulation. So specifically for words, words are things that we have knowledge in, that we have experience with them. We have expectations about what words mean and what letters are meant for what, things like that. So if, for example, you were given this array of letters right here, and it was flashed in front of you for a quick second, CQRN, there's a very good chance that you would mistake that for the word corn. But why? Basically, if you get this kind of array of features, we're going to know that it's a C. We're going to get something that looks kind of like an O, and so on. And so, and you can just see in this particular example about how these different features can correspond with different kinds of letters, that basically once we see this C, and then if we see something that looks kind of like a Q, we're more likely to mistake that as an O, because this would make a word. CQRN is not a word. Corn is a word that we see pretty frequently, and so that would change how we perceive it. And that's based on probabilities. That, in other words, there is much greater likelihoods that we're going to see the letters CO presented in succession as opposed to the letters CQ presented in succession. If we had a language where the opposite were true, where we would be more likely to see CQRN as a word instead of CORN, and we got the word corn, we would still probably be more likely to perceive it as CQRN because of that probability and because of that top-down processing. And so that just calls back to chapter 3 when we talked about this piece right here and about how this letter in the middle changes depending on the context. If we were to see it like this, we perceive it to be more like an H. If we perceive it right here, we're more likely to perceive that as an A because the probabilities of seeing the word the versus the words TAE is much more likely to be seen with the instead of that. And the same for cat, we're much more likely to see the word cat instead of CHT as a word on its own, and so we perceive this primarily as cat. Alright, so that is all that I want to talk about for this video. I'm going to check back in with you in the next video, and we're going to get one step more advanced and talk a little bit about how now that we've recognized these features and now that we can successfully put them together, how do we take those features and add them to others too. Alright, I'll see you there.